Let's talk about pop grains. We use pop grains for creating sand simulation or snow simulation. So let's see how we can set up the pop grain simulation. And in here, first I'm going to create a geometry node. As always, let's dive inside, and in here I'm going to add a sphere. And you know that we need the source for emitting the sand or the snow. We must have a source, so I'm going to use a simple sphere. And right now here, as you can see, we have this sphere and it has this regular arrangement of these primitives. And I can go into the sphere, and in here we have the primitive type. Let's change this to polygons and it will just triangulate our mesh. And here, as you can see, I can see some nice triangles, and I can increase the number of triangles by increasing the frequency. Let's keep increasing this, and let's add a more of these triangles into our sphere. And I'm using this triangulated mesh because I'm going to displace this sphere with the noise, and having the good triangulated mesh will create a nice looking transformation. And after that, let's add a noise onto our geometry. I'm going to use this mountain node. So let's add this and let's connect this and let's view this, and it will just add a noise displacement onto our sphere geometry. And let's go into the mountain node. Let me make this parameter window a bit bigger. And in here, same thing, we have the noise. I can play around with the amplitude to adjust the amplitude of our noise, and I can increase the element size to create a high frequency or low frequency noise. And in here we have some of the noise. I'm going to, let's change this to worldly cellular, and right now this noise is not looking good. So let's go into the range value. Right now they are using the zero centered. Let's change this to positive. And if I zoom out, and here you can see we have a rock looking like deformation. Now our sphere looks like as we have the rock. And in here we can play around with this element size, and we can increase the amplitude, and I'm just keeping these value, and I think this deformation is looking good. And now to create a grain simulation, granular simulation, we have a node called grain source. So in here, if you type grain, here we have the grain source node. Let's add this and connect this, and let's view the grain source. And what this grain source node will do, it will just scatter a bunch of points onto the inside. And here, as you can see, we have some points, and this grain source node is also adding some attribute. If I were to middle mouse button, and here, as you can see, we have an AP scale attribute. Let's go into the grain source, and in here I can play around with the point separation to create more or less of our particles. And same thing, if you were to lower down the separation value, let's say I'm going to lower this down to 0.05, and here, as you can see, I am creating more particles, and that will be our source for the sand. These will be our sand particles. And you know that onto the grain source we have the p scale value, and if you have the p scale on your points or particles, I can visualize them by changing this viewport visualization. As you know, if you right click, and in here we have the particle visualization, so all of the points are also set to be the particles. We can say them that these are particles, and in here right now we are visualizing them as points. I can change this visualization to pixel, and it will just change the visualization onto this viewport to pixels. And in here we also have the visualization to change this to lit sphere. Let's add this, and it will just visualize our points as an A sphere. And here you can see, and because of the p scale we can control these sphere scaling by the p scale. And if I were to, let's say, increase the point separation, and here you can see when I am creating less of my points, I have a bigger p scale value. And here you can see all of these particles, all of these spheres, they are not intersecting, and that's what this grain source is designed to do. It will add points, and all of these points have an AP scale that will not intersect. And I can in here create an A. After that, maybe let's lower down the point separation. Let's lower this down to 0.1. And we have some of the particles. These will be our sand particles. And now let's create a grain simulation. So the grain simulation is a particle simulation, so which means we need to create a pop net. So let's add this and let's connect this onto the first input. And now let's dive inside, and in here you can see onto the pop source we have the use the first context geometry. And if we go back here, you can see we are using the first context, but I cannot see in here my particles, and that is because the emission type, it says scatter onto surface. And if we go back, and here you can see we do not have any surface, we only have these points. So let's go into this DOP net, and in here let's change the emission type. Let's change these to points because we are working with points. So let's enable these 2 points, and here you can see, and right now this visualization gone haywire. So maybe let's right click on it and let's change these 2 points, and let's click again and change this to lit sphere again. And right now it's not visualizing correctly. Let me see. Let me enable my play bar and let's hit play again. And here you can see we have our particles. And in here, to actually create the granular simulation, we have a node called pop grain. So in here, let's add a pop grain node. Let's add this pop grain and let's connect this in between. So this pop grain is a solver itself. If I were to enable the parameter of this node, let me first remove this merge node and let's bring this down, and let me rearrange this node graph. And this pop grain node, it's actually is the solver. So in here we have the option for solving. So these are the advanced settings that we are not going to talk about. These, the default values are just fine, but so you know that it is a solver pop grain. And in here, to create the granular simulation, we use this node pop grain. And in here we have the particle separation, and which means we need to link this particle separation onto our this grain source node. And here you can see we have the point separation. So to control this, I'm going to just copy this parameter. Let's right click and copy this parameter, and let's go into the grain source, and in here let's paste this to as a relative reference, which means I can go back, and in here if I want to create more particles, I just need to lower down this particle separation, and both of these values will going to be adjusted accordingly, and which is always a good idea. So let's hit play again, and here you can see our particles are being imported from SOPs into DOPs, and we have our this sand simulation. Right now it's not looking like a sand, so maybe after that let's add a gravity force in here. So for creating the gravity, I can add a pop force node, and let's connect this in between. And in here let's change this to -9.8, which is a physically accurate value. And I think we need to add a -9.81, and that is a most accurate value. So let's go back and hit play, and here we are emitting our sand particles, and they are colliding with each other if you look closely. And here you will see that all of our particles will have collision, and that's collision what makes these particles look like sand. And before that, if we do not have a pop grain, let me shake this node off and hit play, and here you will see that particles do not behave as if they have collision. They will just move, and after the pop grain we will see some collision happening. And right now we are emitting these sand particles. Let's go into the pop source node, because we are using the point method, which means I can control the number of my sand particle by going on to the first tab And in here I can adjust the number of particles, that how many particles I want to emit. And whenever working with sand, we just want this, we have the sand source. Right now we have this sphere. We want this sand source to be imported only one frame into the our this DOP-net, and our this DOP-net will take care of all of our this shape, and we will going to be simulate this as an sand, as if we have a ball of sand, or we have a sand clumps. So for that, let's go into the POP-net and onto the POP source, and in here let's change this to all points. And when we will change this to all points, which means that if we go onto the first tab, and here you will see all of these options has been disabled, which means we cannot add any more particles in here. So this pop source node will not create particles, it will just import all of the particles that we have onto the source. And if I were to middle mouse button, and here as you can see, we have an 2600 points, and all of these points will going to be imported in here every frame. And impulse activation is on. You know that impulse activation means that we will going to be importing particles on every frame, which means if I were to hit play, and here you will see if I were to middle mouse button, and right now here you can see we have lot more particles, and that is because we are adding that many points. If I were to middle mouse button, that many points every frame, and I don't want that either, because as you know our this simulation is exploding. So to fix this, we need to keyframe our this impulse activation to only just import our this source onto the very first frame. And in here I can place a key by pressing and holding the Alt key and click. I can add a key, and I can just click on this button. These arrow mean we can go frame by frame. I can just click on this button. Now I am on the second frame, and onto the second frame I can just go there and change this to 0 and press and hold the Alt key and add a key. And now if I were to go back and hit play, and here you will see that because we have this interpolation, these value will go first, because we have a between frame in here, because we are working with in the DOP-net. And in the DOP-net we have subframe, so I can enable my subframe. If I were to just zoom in, right in here you can click on this slider to zoom in. You know that that is our zooming slider. I'm going to just zoom in here to this frame. So we have a frame number 1 and we have frame number 2, and frame 1 and 2 we also have some between frame, and right now I cannot see them. And to actually enable these between frame, I can just click on this button, and here we have this option enable playback at fractional frame. And if I were to enable this, and now here you will see that our this frame has been changed to floating point, which it says 1.0. Now if you drag this, and here you will see we have some between frame. We have frame number 1, 1.1, 1.2, 1.3, 1.6, and all the way up to this second frame. So we have all of these between frame. And whenever we are working with this dynamic simulation, when we are in this top context, we will be going to be calculating these subframe. We are also working with these subframe. And if I were to go into the pop source, and here as you can see in between frame we have this increasing value. In this case the value is going down to 0, because at the first frame we have the key at 1, and at the second frame we have set the keyframe to 0, which means that in between we have these interpolating value, and in here you can see that slider is going down, and that's what confusing this pop source node. And to fix this, we can actually go into the keyframe editor. And by the way, you can go into the keyframe editor if you have the keyframes in here, and you can go into the right click, go into the channels, and the very first option is the isolate in channel list. Click on it and it will enable these keyframes. And in here you can adjust your keys, and let me find, I have the impulse activation. and I can see that. Let me zoom in, and here we have the one value, the second value. I can select both of these keys and I can change the interpolation. I can change this to constant, and what that will do, it will just not use the fractional points, sorry, these fractions. If I were to go 1.1, and here you will see that at the second frame we have the 0 and we do not getting these in between values. And that is one way you can fix the problem. Or I can just not use the keyframe. I can add a expression in here. So I can, to remove this keyframe, right click and click on this delete channel, and that will remove all of the keys from our this parameter. And now let me zoom out to all of my this frame range, and in here I can just say that I can add a simple keyframe. So in here $capital F, capital F mean the current frame number, and in here we can say $FF, and if you type $FF, which mean that we are saying that current frame number and the subframe number, this between frame number, if that frame number is equal to 1, I can add the comparison by adding these double equal sign, which mean that we are comparing. So I can add in a simple expression, say that if our current frame number, if that is equal to 1, if that condition is true, we will going to be activating this, which mean that parameter value is 1, and which is only true at the very first frame. And if we go into the next frame, and here you can see right now we are at the frame number 1.1 and our value is 0 because we are no longer at the frame number 1. So that is a very quick expression that you can use to quickly just enable your sources at the very first frame. And in here I'm going to just disable this fractional part, and now if I were to hit play, and here you will see that our source has been imported at the very first frame, and now the simulation is taking care of all of the simulation. And in here let's go back and maybe let's go into the sphere node. I'm going to just move my sphere up so that later on we are going to add a ground plane for collision. And right now as you can see our sphere is going through this grid. So let's go into this sphere and I'm going to just adjust its center to move our sphere a bit up. And now let's view this with the mountain node, and here as you can see by changing this we are also going through the noise because it is a 3D noise. So which mean that if you were to change this, you are also changing your noise sampling position. What I can do, I can just zero this out because I like the noise shape like this. So I can add a transform. After that we have calculated our noise. I can add the transform node, and now I can just move this shape up, and now we have lifted up our source, and now we are using the grain source node, create our grain source. Let's go into our DOP.NET, and in here let's hit play, and now it's going through. Let's create a ground plane for creating the collision. And in here to create the ground plane, in here we have a node called ground plane. Let's add the ground plane, and to actually act as a collider, this ground plane, we need to merge this with this network. So in here I'm going to add a merge node, and let's merge this with our simulation and connect this in here. And because we are in the dynamics, the order of these merge actually matter in this context. So if I were to enable the parameter of this merge node, and here you can see we have the effector relationship, and it says left input affect the right inputs, and we have the collide relationship between them. So which mean that left input should affect the right input, and right now we have, if you take a look at this arrangement, right now we have that is our left and that is our right. So what I want, I need to just rearrange this, and to actually rearrange this wire, just click on this up arrow button and that will just rearrange the order. And now we have the correct order, and now let's hit play, and here you will see that we have the collision happening. And right now I am facing this weird bug of this viewport visualization. Let me see if I can quickly fix this. Let's right click and let's make this 2-point display, and I think that is coming from our this guide visualization. And if we go into the pop source, as you know, we have the guides enabled, and I think this guide is what making this viewport go haywire. So let's go and uncheck these guides so that we do not have guides, and let's right click and let's change this back to lid sphere, and let's hit rewind and hit play, and I think we have fixed the problem. And now I cannot see the weird viewport visualization. Make sure to uncheck this guide. And that is the very basics of setting up your granular simulation. We have this very basic sand simulation, and here you can see all of these particles are colliding, and you know this collision is what makes them these grains particles. That's what gives them the volume. So in the next lesson, let's explore the pop grain node and understand all of these settings a bit better. Let's explore this pop grain node in the next lesson.